Hey everybody, so today we're going to try and basically get the car driving under PlayStation 4 controller control. The idea is to build a so-called RC car, work out all the kinks on the operation between the wheels, and then work toward full autonomy.
Yeah, and we figured something out as well. It turns out the software we had written in the previous part six actually was using software PWM. So it means we don't have to use those very limited hardware PWM pins. We could use any of the pins, and we can have full control over all the motors independently. So that's going to be a big game changer. So we're going to get that working today.
Yeah, to elaborate on that point, one of the bigger concerns that we had is we only had access to 4 PWM pins. We thought, which means that we can only have two of the like we can control the wheels in a translational motion, so you could drive forward, backward, left, right, or on angles, but you couldn't do spinning motion because of the way that the Mobius Mecanum wheels are designed. We couldn't have them all rotating in opposite directions, or I guess in a rotational direction.
Yeah.
But now we think we've solved that problem without having to do anything, which is great, as always.
I like it. And we all know if you can't spin, you can't dance. So today's objective is make that car dance.
Yeah,
It's
looking
gonna be
forward
sweet.
to it. All right,
All right, let's
hope you
get to
enjoy.
it.
Yeah.
Well, so let's take a look at the hardware first. Shall we?
So a couple cool things happened since our last stream. We received our replacement Raspberry Pi. So now we've actually moved up in the world and got our Raspberry Pi 3A Plus, which has Bluetooth capabilities as well as Wi-Fi capabilities. So we don't need to connect over the network anymore. Which will also, if you were around for the end of the last stream, you saw us driving with basically with a cord hanging off the back of the Raspberry Pi, and that was the Ethernet cable to Glavin's laptop so that he could basically run his script from his laptop. But now we should be able to do everything without any cords whatsoever, which is great. We also were successful off stream in getting our PlayStation controller to connect over Bluetooth to the Raspberry Pi, and we wrote a very brief script to try and basically extract all of the data points from each of the buttons. So now we actually have control over both the joysticks, horizontally, vertically, and every mixture in between for both of the joysticks, and then on or off for all of the buttons. So we're going to integrate with that, and hopefully controller motors by the end of today's stream with the PlayStation controller. Again, the overarching objective is get it completed with a controller, and then start removing control and allowing the car to do things itself. Hopefully through some machine learning and open CV, open computer vision.
Yeah.
Anyway, I guess one thing that's going to be very nice by the end of the stream today, this junction point is going to be removed because these junctions were so that we could basically, let's call it splice, or terminate a few cables and basically have them connected together. We won't need these two to be connected to the same thing anymore. We'll be able to connect straight from our motor driver to our Raspberry Pi by the end of the stream today. So this whole plate here will be removed, and things will get a lot cleaner from my perspective. I guess one last thing, maybe Glavin could show us on his computer. We were able to get what's it called? Visual Studio Code.
Visual Studio Code. Yeah. So before, you could see that we were in the terminal SSHing in, either using Vim or Nano, which great ways to edit things, but can be a little bit slow when Lucas and I are not as familiar as using it. So we're using VS Code. It's connected over SSH. It's a pretty awesome experience. It has the full terminal here. We have our code editor. We were able to open up new folders, for example. So we currently open up the documents folder. This is going to really improve as we're going along and trying to edit code and create new files and things like this. Just a great editor experience using VS Code and all over SSH seamlessly. That was a breeze we set up briefly earlier.
Yeah, that was very exciting. Yeah. So I've written down a list of objectives for today. The objectives are simply, our first objective is to do exactly what we've done autonomously, but with joystick control. So that would be horizontal, vertical, and diagonal translations. using the left joystick of the PlayStation controller. Our second step would be to rewire the Raspberry Pi to the motor drivers such that it has 8 PWM pins instead of only 4, so that we have rotational control over the motors. Third, we're going to test the rotation and confirm that 8 PWMs actually work. So basically, step 2 and step 3 are do the thing, test the thing. Step 4, we're not sure how deep we're going to have to go in this, but we believe that it's going to be challenging to integrate rotational motion with translational motion from a math perspective. But we're going to basically have them separated, see what happens, test it, see if that's what we consider enough control. See if we have to go any deeper than that or not. Because basically, we want it such that if you were rotating the car, we would also want it to be able to move forward, backward, left, or right while it's rotating, and we want it to be able to figure that out on its own, how to actually do that motion. So that's going to be an interesting one. That'll be near the end of the stream, and we're not quite sure how we're going to solve those problems, but it might be one of those beat your head against the wall until the problem's solved. And then basically, last step, hopefully by the end of today, is to have everything working from the PlayStation controller so that we have full PlayStation 4 control over the car, as if it were out of a box. So it's a very exciting stream. Today, if we're successful in all of our objectives, I would suggest that today would be the biggest step toward beginning to build an autonomous car. Anyway, so let's get rolling. First step is start working on getting one joystick translations. Yeah.
All right.
So I'll come over with levers.
Let's do it. So we have our code from last time that we're going to pull over. Here, I think it was called all motors test or move in direction. The move in direction, what we were using. Yeah, so here is some code. I'm just going to pull it from our last Raspberry Pi. Move in direction.
You should put the string back up once you're done that.
And so what we're going to do here is just demonstrate we have what was working previously working again. And you've already set up all the pins, so that's...
The pins should be set up to match what they were at last.
Cool. And that's 35, 33, 12, and 32. All right, good. So if we save this, we can open up, I'll save this here, plan for today.
The restream chat isn't working.
Oh, there it is.
Oh, never mind, just delayed.
It's just slow. Hopefully that speeds up. Okay. So we want to get this car doing the same thing we had last time. That we have the move in motion, which previously connected to the 4 different motors and ran this script we wrote for move in a circle. And move in a circle is just going to take it's going to start at 0 and then just keep picking the direction around the circle. It's going to go to the maximum of 2 pi, so that is a full 360-degree rotation. And we're just going to break that up. I think, what is this now? Maybe 1,000 pieces. So it's just going to seamlessly go in a circle and just try to move on the circle there. So we can give that a shot if you want to give that a shot first.
Just where we're at?
Yeah. Make sure it works with the new pi. Everything all good.
It's a good idea. It's a great idea.
And then we could say we have one script that we have for using the joysticks and the PlayStation controller, another that we have for moving the circle, which given an angle will move. And we can say now, get the angle from the PlayStation controller, pipe that into our previous code, and now we can control it seamlessly. It's going to be sweet.
So to do that, you can put me on, if you want to put me on a bigger screen, just so that I can show the connections. So this will be a pretty simple setup, except we're going to lose connection to the Pi when I connect it to the battery.
That's right, we can just reconnect.
Okay, cool. Just warning you. So
make sure everything's saved. Yeah, it looks good.
Unplugging the Pi from the wall power source and plugging it into our battery power source. What's really nice about the Raspberry Pi 3A Plus is it's a very small form factor Raspberry Pi. So we actually basically gained about an inch of space between the buck converter and the Raspberry Pi, which is great.
For comparison, here is the old one. Here's the new one. You can see lots more USBs. We have the full-size Ethernet, and we have actually 5 USBs. That's HDMI. Yeah, so this is quite a bit better.
Yeah,
easy to work with.
Yeah, it definitely saved us some space, and I was doing some reading about a problem with our Raspberry Pi that we had previously when it stopped working, and I have reason to believe that I may have fried it, and that would have been simply by having the Raspberry Pi sitting on a metal plate while it was energized, and I might have shorted a 3.3 volt supply with ground, which would end up resulting in somewhere internally on the board something was fried, and I now have reason to believe that it was my fault. Either way, we got a new Pi, so problem solved. I need tape or something. Do you have tape?
What are you going to take on?
I just want to tighten
I
this.
see that. Yeah, I'm sure I could get it. I don't know how quickly though.
Here,
So this is totally wireless. We don't even have the cable from last time.
that's correct.
Oh my gosh.
Yeah, this is going to be phenomenal.
Yeah, I just take the tape.
Tape.
I like it. Table tape. Is it plugged in again?
Yeah. Not underneath.
So just powering it on. Everything's been powered from the battery.
Alright, everything's powered from the battery
I
now.
think this is the first time it's actually been remote. Everything else has been, we've always been holding it.
They've always been tied together. Yeah, so I suppose we might as well just do the demonstration. Put it on the floor and show basically what we did at the end of the last stream.
Yeah.
As a repeat. That looks really good without a cord hanging off of it.
Yeah.
I'm a big fan of this.
Completely wireless. This is going to be great.
Battery on the bottom.
All the soldering there? Yeah.
All the soldering, yeah. Some of the soldering points are great. Some of the soldering points are okay. Some of them are very bad.
Yeah.
Do you have access to the Pi?
I do. So let me just.
I'm gonna actually
get
use
that
your
connected.
camera. I'm gonna disconnect this.
Okay, good. So you see it there. I'll just move the chair your way so I have a little more space.
Thank you very much.
We're going up here. I don't recall how big the circle was, but let's see how it goes.
I think somebody joined the chat.
Oh, great. All right, we'll have to check the chat.
Hey Tetsu, how are you? Hope things are going well.
Excellent. You're able to see the chat. Engineering, yeah.
Oh yeah.
It's gonna get good. You joined at the right time. Okay, so here we are. Let me show you the code as well. So we are now connected over SSH to this Raspberry Pi 3A Plus, which is wireless, so that's fantastic. So no more cord that Lucas has to hold on to. And we have our move in direction script connecting to all the motor pins from last time. So we're just gonna recreate what we had last time with a new Raspberry Pi. Okay. Python 3, move in direction. All right, you're ready to record, and in case it drives away, we can jump on it. All
I
right.
can't do both of the things.
I will jump on it if need be. All right, 3, 2, 1.
There we go. Beautiful.
Nice.
So Tetsu, if you didn't catch our description last time, basically we have the car programmed such that it drives in a circle through translation. So it doesn't turn; it just adjusts the wheel's directions. The wheel's directions. You can probably see it from this angle.
Ideally, it should be facing. Oh,
That was interesting.
I think we lost.
We lost a motor.
Oh, that's not bad.
It's smart. Something's not working. No, it looks fine.
Maybe it's working now. Maybe it just got dislodged for a moment.
Oh, okay. Could be the battery. Maybe I didn't charge it enough. Seems to be getting longer.
What if it's the battery? I'm just gonna kill the script.
Sure.
All right, so something's off a little bit, but it did work initially, and maybe the battery is the source of the problems.
I hope so. I'll plug it back in now.
Yeah.
But that's okay. That was a good starting test. If that's the biggest problem we have today, we're doing all right.
Yeah. There we go.
Except the problem is 10 minutes into this.
Oh, how can you charge the battery with the Pi out?
I'll just plug the Pi back in there.
All right, because we're gonna have to switch back and forth.
We will, but we're not going to be doing a lot of testing. We got to write the script. Like, it's going to be
Cool. It'll be a little bit. Yeah. Okay. Yeah, because we already know the motors work.
Yeah.
So let's code for a little while. Have a little trust, a little faith.
a little faith. All right.
Very good. So we have our car back. That's gonna be disconnected and charging.
Just zoom out a little bit. Yeah, we're doing pretty good. We're doing pretty good, Tetsu. This is good. This is a very fun way to spend a Saturday. I'm not sure everybody in the world would think the same thing, but this is very exciting, and especially where we're at in the project. This is when things are about to start getting quite cool, at least from my perspective.
Yeah, I'm really excited about it.
We need to. I don't know if you weren't here last time, but we need to install a switch between the battery connector. It's very challenging to actually disconnect this. And that's our only means of disconnect. So we have to put a switch in and basically splice into, make a connection between these two. If I knew how to do stuff like that, I think it'd be pretty cool. Yeah, you absolutely can do stuff like this. Hopefully you hang around long enough and you kind of learn a couple things, and then you want to a Nintendo Switch. Yeah, exactly. I'll put a Nintendo Switch in the middle of my circuit. That'd be great.
Yeah, but definitely this is the goal. Is to hopefully other people like yourself and me who don't know don't know the electrical engineering side of it, for the hardware, and for Lucas for the software. Right, we're all learning this together. We have different skills we're bringing to the table, and hopefully we can build this thing and learn together. So if you have any questions, feel free to let us know. We're all learning this together with the intention that we can build more projects, things like this in the future.
Absolutely. Absolutely. Everything's a learning process, and it's sometimes you have to beat your head against the wall until you get something right, but sometimes things just work, and you can pat yourself on the back and maybe have a drink afterward. It's all fine and dandy.
Yeah.
All right, back to the code. I will plug this in.
Yeah. Once that's all plugged in, we'll bring it over. I'm just checking our camera setup, making sure it's all good. Please bear with us.
Yeah, I'm gonna plug the battery in. Sounds all good. I do like these wheels. These wheels are nice and heavy duty, so I can actually just lift. One thing that we did, Tetsu, which I'm pretty happy with, was I bought like a large amount of Velcro, so everything's just Velcro to the car. It's really easy to take it off, put it back on. It's just little Velcro strips taped to everything. It's awesome.
Yeah, the Velcro's a great idea. That's helped quite a bit.
Yeah, I think it was. I don't have a lot of bright moments, but that was one of them.
Right. Connected.
So battery's charging. I don't know if the battery is the issue, but we'll let it charge for a bit.
Okay. Well, unless there's some looseness in the wires, we can check that later too.
Yeah.
But overall, it did look like it was going in a circle until it hit this.
Yeah. The looseness kind of makes sense because of that.
I did notice our camera's taking up our memory again.
Was it?
Yeah. That would be a little concerning. But it's okay. It'll kill us a little bit.
Is it taking up as much as it was last time?
Well, it's at 2.65 gigs. It's climbing. It's
Well-
not as much, but it's like climbing without going back down.
How do you have to close it?
I have to restart OBS.
Restart OBS.
Yeah.
Wow.
That's what we did last time. So I'd very much like to avoid doing that.
Yeah, that sounds rough.
I,
didn't realize there was some. I was wondering if you could like disconnect the.
Yeah, I changed the resolution. I want to see if it actually goes down, but I don't see it doing so.
Yeah, so Tetsu, I'm just going through all of our connections right now to see if anything got a little bit loose, a little bit dislodged, and then ran into to the carpet. Hopefully not. Seems fine. Hmm.
Okay. Yeah, it didn't seem to go down when I reduced the quality.
Darn it. Well,
So we might have to have intermittent pauses every.
I mean that's
Couple
not the end,
hours.
that's not the end of the world.
Okay, cool. Well, we'll keep monitoring that for now. But yeah, in case anyone wonders, we might have to pause in a little bit just because our camera is having some difficulties. But for now, we're looking good. So let's get back to coding. Is it all plugged in down there?
Yeah.
All right, sweet. Okay, so we're just reconnecting to the Pi now that it's charged, plugged in for power. Sweet, back to our program.
Tetsu, yeah, that is a good question. These wheels, there is a good chance that we'd run into some pretty significant issues on carpet versus hardwood. These wheels, the rollers themselves are rubber, which is nice. A lot of the designs come with plastic wheels, which actually make the hardwood the issue, not carpet so much. But since there's such a small surface area for contact, I would suggest that carpet would make it challenging to do sort of, I guess, finer movements. It'll be able to move forward, backward, left, right easily, but as far as moving diagonally, it might struggle a little bit. Yeah. Well, but I suppose at that point we'll find out realistically, at this point, we've done most of our testing on hardwood, which seems to work reasonably well.
So just getting this set up.
You setting up?
Okay, so we got this. So we want to get back to the PlayStation controller.
That's right.
Is that this script here?
Yes.
Okay, excellent. So let's maybe do a demonstration of this.
Okay. Yeah.
So we have the controller.
PlayStation controller's connected.
Actually, while I'm at it, let me just move all of this stuff in here.
Oh, it's not connected. Remember when I said it was connecting so easily?
Uh-oh.
Do you want to run that script? Let's see it.
Yeah. PlayStation controller. Invalid joystick number.
I'll try again. Should we get it?
Yeah, now you're talking.
Yeah, so here, leave it on that screen. I'll show you.
Yeah.
So what's happening on Glavin's screen right now is basically we have all the inputs for our PlayStation controller. We have access to all the true false data for all the buttons, and access to horizontal and vertical data stream from the joysticks, which realistically are the most important inputs for us. I think most of our actions are going to be done with joysticks. It'd be kind of like driving the Warthog from Halo. Do the cars in Warzone drive like Halo Warthogs? I don't remember.
I haven't played Halo in probably like a decade.
No, you trigger to drive in Warzone.
Yeah.
Because Warthog is all joystick.
All joystick? Oh, okay.
Yeah.
I see what you're saying. Yeah, that's a good question. How do we want to do our
Do we want trigger or not? I'm not sure.
Well, the other interesting thing is, so I guess it makes it simple if we say it's only using joystick, because we already have speed, like magnitude, outside of zero, outside of center.
Yeah.
So that makes it pretty clean cut. So that'd be like Halo, then?
That'd be like Halo.
Drive like Halo.
Drive like Halo.
Yeah.
Yeah.
And I think that's relatively intuitive, too, because you just point and shoot.
I think so.
Go here. Yeah.
I think so. Yeah. So we won't bother with a throttle. We'll go straight to joysticks for magnitude and direction.
Yeah.
I think that's the play.
Okay, I like that. So I copied here just a quick response of what it looks like. Now I think I probably copied the wrong time, but one of these values actually ends up represent. I think it was this one here. Yeah. So if you go full right or full left or something, yeah, full right. So full right is. Let me just save this. So here's what full right looks like, and I'm guessing it's actually this value here, maybe.
You should see it change here now.
So what are you doing right now?
Full. So I'm just going.
So right is that. So that's what we have, and what about left?
It's actually the leftmost. So that first, the negative one. Yeah. And then.
So this 2 value, I don't know what it does, but maybe that's just something else. What about up? So this is left joystick. Actually, maybe you want to put your. Do you want to put it under so you can show?
Oh yeah, absolutely. Yeah, so basically we're just trying to map out all of how the data stream lines up with the controller's action. So full left.
Okay, so full left is this. So we have full left recorded. Check. How about up?
You can't see that part of your screen. Just a heads up, because of the cameras. Like look at your stream. Look at your stream.
Oh, I see. Because of the cameras. Thanks. That's a good point. I did tell myself I wasn't going to use the bottom as much, and then I did. Let's see.
You could just shrink that. You could shrink this screen. With the right analog control left and right, and the left would be forward and back, or you're going to do just one stick. I never played Halo, so I'm only used to the trigger gas. Yeah, I absolutely understood. So our strategy right now is the left stick is going to be translations, let's call them. So translations being like push the car left, push the car right, forward, back, and diagonal. And then the right joystick will be rotation. So if we want to spin the orientation of the car, that'll be all done with the right stick. All right.
Yeah, exactly. Now that being said, with the right stick, yeah, we'll talk about that in a second. So goal right now is just to get translation working. So this is using a left stick right. Okay, do you have up? That's up. Okay, 1 second. Okay, and then down. Okay, very good. So we have left, right, up, down. So if we look at this is right up here. So right seems to edit this value. I think we can ignore these. This is probably slightly off. So this 0 value is horizontal. So +1 is right, -1 is left on the 0 value. There's 1 value, up is -1, and down is +1. So if you think about this in a Cartesian plane, let's think. So right is positive, left is negative, up is negative. So if you look at it as a box, negative values are over here, I think, and the positive values are over here.
That feels right.
Does that feel right? So that's a good way for us to represent it. Now, we are actually able to provide an angle. So right now we're given x and y coordinates, and we're saying, okay, given x and y, what angle do we want our car to move? So we actually have to do some translation there to go from.
So here's a 45 degree up to the right.
45 up to the right, yeah.
So that's an example of
up, right, 45 degrees.
That's an example, and that should be enough information for us to start thinking about.
So now we can do something a little bit smarter, and I think the objective would be, given we have this circle, what angle do we want it to go in? Now, one thing we don't know is if we give it 0, if we say go 0, does 0 go left on the car?
Go 0. What do you mean?
So if we're trying to map that controller to a circle,
yeah,
right? Where does the circle start on the car? So for example, that might have on the point and circle Good. Yeah, we just
Center point of the car. Forward.
Forward is.
I don't know what you mean.
So like what might end up happening is we do the math and we say, okay, given left, here's the values, but so if we rotate around here, that's the circle, and we were already doing that, so this would go like this, right? But this left might actually be this forward, like they might be offset circles, for example.
I don't think that's the case. I think that this is always that.
Right. We want that.
Yeah.
Yeah.
I mean, we have to define that.
Yeah,
but
we want that. I'm curious to see, like, if we end up coding it and have this, so that this maps to a circle, rather than being x, y coordinates, up, down, left, right kind of stuff, and we code it down to the angle. So is this, if I put this 0 angle, and this is, a higher angle and things like this. Okay, so this is 0, and this is 90, and this is 180. This is 270, and this would be 0, not 360, right? So there's your wheel angle that we were originally providing to this to say where it would go. So left is 0 in the case I just described. Hard left is 0. What is 0 relative to this car? And if we give it 0 in the current code, is it left, or is it right, or is it straight? Like what is it 0?
Well, I think that the easiest way is set this to 0. And say that.
So we'll say whatever this is, make sure its 0 is straight, and we'll make this 0 straight, and then it solves it.
Yeah.
Cool. And then that's one value, is to get this to convert from the x and y to being angles, and then the other thing is also deriving the magnitude. So we have an angle, we have magnitude, and that's going to be the speed of this car in any of those directions.
What did Tetsu say? Tetsu says it looks like your up and down has sensed the slight off-center relation from the stick being out of those dead zones.
Yeah. So 0, 0, that's correct. So 0, 0 would be here.
So
and then you're around that. Yeah, I think that would be an accurate way of representing it. Now it's interesting though. So obviously, this only moves in a circle, but it's represented in a 1, or maybe it's a 2 by 2 square, because it's two width, but it has bounds of -1 to 1.
Mm-hmm.
Versus we actually only have a circle. So that's pretty interesting, because if you go at 45 degrees, for example, like that's -1, -1, but we have to make sure that's a unit circle. Yeah. So there's gonna be some interesting trigonometry there, but
it'll be okay.
Yeah, that's all good.
Looks like your up and down sensed the slight off-center relation from the stick being out of those dead zones. I think what Tetsu is suggesting is that, or I think he's commenting on the fact that we can get partial values. So if we're slightly off of 90 degrees vertical, that, like, let's say 90% of our direction is up. He's just noting that we have that visibility. That it's only 90%, not 100%. I think that's his comment. Is that your comment?
I thought it was more of that 0, 0 in the middle. When you've applied no force to it, 0, 0 is in the middle, and essentially everything up left is negative, and like that's the dead zone. Middle being dead zone, center dead zone, and then everything's just relative to that.
Yeah. I think he's just commenting on
the mapping for down. You have 0.02, for example.
He's commenting on the accuracy.
Okay.
Yeah, I think it's just a note.
Yeah, no. Yeah, that's the thing. So you probably want to have a dead zone in there as well.
That's actually a very good point.
Yeah, that's a good idea. Yeah, because otherwise we'll just sit the control on the table and it will still drive and move around.
We want it to move around if we put it at 0?
No, I'm saying otherwise. If we don't have a dead zone, it will just move itself around.
That's
right now,
it'll drift a little bit.
It will drift. I think it's fine right now, but it might not be later. Okay.
Well, it's actually pretty good.
It looks good right now.
Yeah.
I wonder, does it give us? Is your controller just good, or does it actually? I wonder who accounts for the drift. Up and down, we get 0.2.
My controller's just good.
My controller's just good. Yeah, interesting. Okay, let's give it a shot.
Yeah.
So that's charging already. Do you know how long those things take to charge?
It'll just charge. I'll just leave it charging until we're ready.
Okay. So we have the PlayStation controller code. Let's just make a new one. new file there that we can work with.
I think you can get rid of that .save file. I think that was an accident.
Yeah, it's probably for Nano or something. But yeah, I'm not bothered by it.
So
Joystick control motors.
I'm gonna take a piece of paper.
So I'm gonna make the base of this is actually gonna be the Python control code. Let's actually do a bigger one. Coding with face. I'll make this bigger. All right. Let me know if you can't read the text. So we have our joystick code. We also have our move code. All good for me. Excellent. Thanks very much. The move code here. So move in a circle called our move with angle. So move with angle is actually something we want to keep. We're going to replace the move in a circle. So move in circle, just picture a clock. It just goes around and around. And that's what we were doing. We were just going from 0 to 360 degrees and just moving that angle around so it would actually move the car. We're going to replace that with the joystick. And the value we need to derive from the joystick is this wheel and angle. So everything above here is actually what we need. Okay, let's go here. So we have, it's a Pi game? Is that how it actually
That's what takes
the joystick? Very cool.
Yeah.
All right, so we have what we need for communicating with our joystick. We have what we need communicating with the motors. This speed coefficient, I think we'll probably change it.
Well, that speed coefficient
that's constant. So that's going to be throttle.
The amount of direction on the joystick.
Would throttle be a good word to use?
I don't know. Gas.
Gas. God dang it.
See, the typical term is gas, but that's
give
not
us some
proper.
gas.
It's not technical.
Yeah. Speed coefficient is also not great. That I put last time. Okay, so we have here. Actually, this can actually answer our question. Move backwards. Move the speed forward, backward. Move angle. Yeah, so somewhere in here, we'll be able to determine, make sure all the angles line up. But that's okay. So this is fine for now. I don't think we're actually using go backwards. No, we're not using it. Let's get rid of that. These are our motors and some other setup stuff. So we'll leave this for now. But I think there's quite a bit we can do in terms of cleanup. So move with angle. So that's actually what we want to be changing. And down here. Oh, sorry, I went the wrong way. Move in direction. So move in a circle called move with angle and give it a wheel angle. So what we should probably do is get joystick controller to print out an angle so we can go, and you want it straight, forward to be 0?
Forward
to 0?
Yeah, forward to 0.
So that's something we can do, and get that working. So let's joystick controller. So let's save this. So we might have to do a little bit of trig to make that happen. So right now, where did I save this? Here it is. So right now we have this coordinate system. We want to get two pieces of information. We want to get the angle that would create this coordinate system, and we want to also get the magnitude of that length.
So we need to build a vector, basically.
Yeah, we need to build a vector, and it's relative to 0.00. Actually, that might even help us if it's relative to 0.00. So if it's straight, we want this to be. Let's do some examples because many examples make it. So examples. So if we give it something, so if you're going up is here. So if we're giving it, I think that's roughly 0. So it's roughly 0 and -1. So 0, -1 is up. We want to map that to 0 degrees. So that's our mapping that we want to do. And actually everything's technically in radians as well, so that creates a whole nother.
Why do you say that?
Well, it's because it is in radians. So our actual movement code here, all the math is done in radians.
Right.
In all the stuff here, which makes sense. That's how it works with the sine. Isn't that a thing? You have to convert I think you have to convert your calculator to like do in degrees mode.
Mm.
So our stuff by default is work in radians, and that's what a lot of people will be working in. But I think that's fine. And if we needed to convert between degrees and radian, that's another simple thing we can look up and do. So that's 0 degrees. We want to have down. So our down here is also 0. So 0 horizontal and positive 1. Cool. And that is, so down is the opposite, so 108 degrees.
Mhm.
And we'll convert that to radians in a bit. And then I think we'll just do a couple more just so something to have tested. So then we know if we see this input, we expect this output. 1 sec, I'm just gonna let's make it a little easier to compare. So left was up here, so that's negative for the horizontal, and it was 0. And so left is going to, so we're only gonna have positive angles. We have 0 to 360. So left is gonna be 270. If front is 0, 99. So then this is going to be the one that's 90 degrees, and this is 270 degrees. So right feels so much better in VS Code. This is great. So right is up here. Right is positive 1 and 0. Boom, boom. Okay, so that's what we're expecting to get. Let's work on it. We can get it degrees or radians, whatever's easiest for us. But that's the kind of math we want to be able to do. Now,
No, go ahead.
I gotta do it. I gotta think about how to do it. Okay, so what do we have to do here? So if it's going up, it's going negative. So maybe we need to draw. I might actually draw it over there, so then they can actually see our drawing.
Sure.
Yeah, let's move on over to here so we can actually see us draw a little bit. Now bear with us because this is a little bit trigonometry and it's been a while.
I can move this up screen.
Alright, let us know if you can't read this. So here's our 0, 0. This is our 0 degrees. If I recall correctly, all trigonometry is based off right angles, right? So, so if we have, so in this case, this one here we're saying was up, and up is 0, 1. So 0, 0, negative 1 was it? Yeah. 0, negative 1. So this over here, if you went 45 degrees, this should be negative 1, negative 1. This is positive 1, positive 1, if I understand correctly. So there's your dead zone, there's your square. Yeah, should be like that. So if we have not moved, so it would be the same as a, how do we do it for a whole circle now?
That's not -1. That's 0.5.
Oh, I see. So it actually is this value. It's not. It doesn't give us this. It gives us this.
Yeah.
Oh, I see. So that actually might make things nicer then.
Yeah.
That's nice. So there's actually points on a curve. I wonder if
I'm wondering how throttle works now. I'm confused.
throttle works.
Magnitude. Magnitude of
Well, because it should be able to give us this value.
is that a separate value?
Yeah. It's a separate value.
Do you want to run it again? I don't know.
Yeah, we can run it and just have it in that thing.
Oh, it is running. Never mind. I'm good. I just want to take a look.
Okay. Oh, I can't see.
Wish it didn't flicker so much.
Yeah, I don't know what it needs to not do that.
I don't know, but it's okay.
Okay, cool.
I'm just gonna. Yeah, you can go back to your drawing if you want. I just want to see. Yeah. I confused myself. Now I need to get out of that.
Yeah. So let's say we are. So if we're given horizontal 0 and a -1, so it's up 1 here. This is 0. So I think everything is described as a right angle. In this case, I can draw up there.
So there is a pretty big dead zone. I see.
There is, okay.
Yeah.
Okay, so that's the right angle. So I think what it actually means is it is horizontally over by
Yeah, it's not quite what I thought.
1 away from this, and then it is up. So this is 0, so it's useful. Let's say it was something else. We should just look up something in tricks.
It's not quite. Look at this. It's not quite what we thought. That number represents both quantity and direction at the same time.
Yeah, it's important. So you can get something that's not on the circle. You get something inside the circle.
Yeah. Yeah.
Yeah, that's what I figured. Yeah. I wonder if you just Google this, and someone else has probably done it.
Sure. Here, I'll give you that browser. Give you control.
Yeah, there's gonna be others, like, as I'm sure we could figure out the trigonometry right now, but I'd love to just not have to do it. Let me see here.
What's that? Stream that refresh. Oh, it's not coming up.
Yeah, I can just hit live right there. I'll catch up. So let's take a look. I even wonder if this Pygame thing has that method built in. So your Python control code. It has a joystick. It has these events. Access to print button data access angle. So we actually don't need buttons, and we don't need the hat. It's actually I'll leave this here and I'll do it on this one. Don't need buttons, don't need the hat. So Python 3, and actually this should be Movies car. Joystick. Can you move it? Oh, maybe I commented the wrong one.
Well, that was right.
Oh, it was right. What?
It doesn't bring it up until you move.
Oh, interesting. Okay, cool. That's fine by me. Oh, I see. Because it's setting the value in this object. All right, good. So that's a little bit quicker. So you're doing
Oh, right. That was done. So it's quantity in the left, quantity in the right, quantity of. I think I just confused myself. I think I went down a bad mental path. I overcomplicated.
joystick to angle.
Noise.
How do I get angle? So Stack Overflow is great. Use the arctangent function. Whoa, there's literally a function that just does exactly what we want. Don't call if both are 0. So don't call if we're at the dead zone. Now this will give us, so actually we can just test to see if this works. we'll do the test in JavaScript because I'm lazy. So math, arctan. Actually, let's just look at JavaScript math.
Hey, Nacho Kitty, how are you?
I'll do Python math. That's fine. So we want to look for the arctan2 function. Atan2. There we are, and it's in that library. Okay. So access data. So I'm just going to cancel this one. It will just open up Python 3 REPL. How do I import math? Import math.
Python, man.
Python man. All right. So we just take math, a tan 2, and it's given an x and y coordinates. So we already plotted out what we want to see. So if we give it 0 and we give it -1, so it gives us 1 pi. So 1 pi.
That should be 180 degrees.
Yeah, 2 pi is a full circle. So it's thinking this here is right. So we probably want so that.
So we'll have to just offset it. So subtract the pi from everything.
Yeah, exactly. So yeah, and that's perfect. So we just do this calculation, then rotate backwards, and that's fine. So if we do this, it's down. So down is their 0. So down is their 0. So if it's up, it's a full rotation, 180 degrees. Yeah, that's perfect.
1 pi.
Beautiful. All right. I like that a lot. So okay, we solved it. Yay, Googling. Google first helps you. It's good that we understand it, though. You know that we so we can look at this. Gives you the angle in radians multiplied by to get degrees. Okay, that's fine. So this is perfect. It's exactly what we want. How do I get rid of this right now? Go away, please. So we got this. We figured out how to do it in Python. That's great. And we tested our assumptions, so it looks like it all works. So if we were to go into here and say, let's see, our code for the joystick is access. So access data here is this empty object. I would like to actually make it preload as something. So right now, if I were to run this, it starts off as empty. And if you do this, it fills up. If you do this, it fills up. So I actually want it to be filled already.
Why?
Because then, see, I want this to be default. Because then I don't have to have other code later. Yeah, why is a good question. I don't have other code later that says, are you a number? And then if not, I will fill in your values. I'll just make sure that you're always going to be at least 0. So 0 is our default. Every calculation will be based on 0, and that just standardizes things. 3. Oh, interesting. It skips.
Yeah, that's bad code.
That's just weird.
I would assume.
It might just because maybe there actually is a 2 somewhere. Like 2 represents something else.
Oh, maybe.
So we have not touched the controller, and it's now giving it out of the box. But I'll be out of reach of the keyboard. Cool. Yeah.
Okay,
Thanks for keeping watching. It's gonna get interesting soon. We're making good progress.
Yeah, we definitely appreciate you being here, though, Tetsu.
Yeah.
Yeah, it's great. We like either way we would be talking, but we like not just talking at at our computers. It's nicer to talk to people.
Yeah, that is for sure. So I just want to understand in the code that you written here, Lucas. So this is data pretty printing. Okay, that's good. So I don't need data pretty printing anymore. I'm just going to print out some values. So I don't need to do that. And that's just using the print command. Okay. So if we say we're going to use math, Atan2, and we're going to give it the joystick 1, or what's going to be joystick left x is equal to self axis data, and it's going to be 0, and this is y, and this is the first value. So we know we have both these values. now we can take them and put them into our atan function. And this is our kind of raw angle. And we'll say the raw move angle. And we'll say there's another one that is final move angle. And the final move angle will just be the raw move angle plus, how do I get pi?
I think it's math.pi.
I think you might be right. I think I had it over here. Yeah, math.pi, and pi is lowercase. And you said it was just 1 pi? Cool.
Yeah, 180 degrees.
Boom. And now let us print this. And I'm going to get rid of this and this. So now we just print this value. That's all I want. Now the only thing they said is if it is 0, do not pass. It is between negative pi and pi. That's good. Oh, or maybe it's not. Negative pi. So it doesn't go the full circle. It does a half circle in 2 directions, I think. Because it's negative pi and pi, not pi and 2 pi. Vector plane cat is fair. Use the point of signs.
That's just because you're going to be multiplying by a negative number.
Yeah. Compute the quadrant. Okay, good. So that's fine. The only thing is is it with one of them or if both are 0. Okay, so if both are 0, we don't want to do anything. So if joystick X is 0 and joystick for Y is 0, then we want to do something else. Otherwise, we're okay to do this. Is this still valid Python? Okay, I'm coding it properly. Move wrangle. Actually, I'm going to do one step further. I'm going to do this. What is the default? Is it none? So that just means we have no angle. And I'm hoping it's actually going to print out the word none or something like this. So it's very clear that we shouldn't do anything. Okay. Yeah, because then it's not like pointing towards default, pointing toward, it's not saying, oh, keep going forward. If we were to return 0, for example, 0 as the the final angle to move is actually going forward. So that's incorrect. We actually, by dead zone, we want it to not move anywhere. So we're just going to provide no angle. Okay, how do I convert again? I think everyone works better in degrees, probably.
I think you just add 57.
Convert x from radians to degrees.
That'll work.
Cool. It must be a real number. Oh, yeah, that's stupid. I'll just put this inside the if. So essentially, if we're at dead zone, do nothing. So where's our yeah, so forward is about 360 or 0. And if we go right,
It's going to reverse.
yeah, it might be reversed. So right, yeah, it's going to reverse. So left here is closer to our 90. There's our left, and that's actually what we expected for right. Is that a problem? What does that mean for us? So if we're going this, so 360 or 0 is forward. We go left is 90. Oh, so it's going counterclockwise.
Yeah, which is fine because we're just mapping those values to our motors anyway.
Yeah. So we just have to make sure that it accepts a counterclock and they're mapped correctly. Okay, so I think joystick to wheel angle is good. Now something we are missing, if I move it very slightly, it still gets the angle, but I don't have the magnitude.
So we might have to use throttle, the right trigger throttle.
No, we should be able to do it. We need the ATAN, but for something that gets magnitude. So joystick to I don't know what it's going to call it. Magnitude? Magnitude is probably the wrong word. I use magnitude, but intensity of this, maximum direction, map of the squares. There's probably like a bunch of things. It's probably going to be something involving tan again. There's clamping involved too. So what did ATAN do anyway? ATAN 2. Oh, Euclidean distance might even be. So if we do Euclidean distance, yeah,
instead of ATAN.
yeah, we just use Euclidean distance. So we already have an xy coordinate,
Mhm.
and I want the distance between 0, 0, the dead zone, and xy. And that's it. I just want Euclidean distance. So I'm just going to draw a straight line
To the point.
to the point, point to point. So let's give that a shot. So math.dist. Now, how does it do it? P and Q, 2 points, given as a sequence or interval of coordinates. The point must be the same dimension, equivalent to this. I wonder if when they say 2 points, if they're talking about it, there are 2 points, sequence. So I'm guessing it's like an and yeah.
Which is what you get.
Yeah. So that's fine. So this works, and the other one we want to do is getting. I'll just call it speed for now. Math.distance, and we're going to be using 0, 0 is our dead zone, and our joystick X and our joystick Y. And cool. So we'll just print speed. Oh. What? Math.dist is a thing. Yeah, what did I do wrong there? This is Python 3, yes. New version in 3.8. What Python 3 are we? 3.7. Yes. Okay. Of course we are. Well, let's just update it actually. So Python 3 is probably from apt-get. I actually don't remember how to do anything in apt-get.
Apt-get install update.
Update retrieve new lists, upgrade a particular package. Actually, let's just. I don't want it to stay too long.
It won't take.
Okay, I trust you. All right, especially since you just set it up. You probably ran an update already. So we're going to update to make sure it has the latest registry. God, it's sudo for everything on this guy. We'll update the registry, and then we're going to upgrade the particular package, which is Python 3. And then that should give us at least Python 3.8, which will give us the dist function. So that's going to give us the distance between 2 coordinates, our dead zone, and the coordinate we're giving it. And that's it. So now we have angle and we have magnitude. Boom. Let's drive the car.
Oh yeah.
Yeah.
Woo woo.
I like it. And thank goodness for people on Stack Overflow that know trigonometry. But that's the thing. It's incredible. If you look at this page, right?
Python math library is really well done.
Yeah, this is a really nice doc. And it's funny, even the documentation, if we actually read all of it, this actually, based on the description, makes a lot of sense. The vector in a plane from the origin xy makes an angle with the like it's talking about this xy coordinate system and how it's breaking down into quadrants, and there's negative value. Like this kind of makes a lot of sense. We want x, y. Oh, y, x. Hey,
That's why we got the opposite degrees. Yeah.
That's why y, x. What did he do here? Yeah, he also gave a y. Okay,
so we just put those in your.
Yeah, let's fix that. Y, x here. This is why you read, everybody. Don't be like us. Okay.
Don't be
So.
Check your version, see if it upgraded.
No, I didn't do it yet. I'll do it in a sec. Okay, so forward. Actually, we might not even need to do the plus 90, because if I do this,
Oh, you get 90.
I think it's just correct now. I think it is already. So that's 90. So I need. Maybe I do need to add plus. Oh, I need half of it. I need half a pi. It's 90 degrees off, not 180 degrees off. So 0. So that's forward. This is right. This is back. Beautiful. Done deal. Boom. All right, now let's upgrade and get this disk function going. So apt-get upgrade, I think is what I want. Python 3. Oh my god. I'm going to do that a million times tonight. You know how you get someone to make you a sandwich? Sudo make me a sandwich.
Will you make me a sandwich? No. Sudo, will you make me a sandwich?
Works every time. All right, so once we get that working,
Just to get you to stop talking.
pretty much, yeah. Sudo mute. Big oof. So what we don't have right now is move with angle takes wheel angle, and this speed coefficient, we are not providing that as an argument. So what I would like us to do actually is we'll actually pass down speed. I'll put speed coefficient just like this. So now we're actually passing it. We don't need it hard-coded above here, so we'll comment this out. And down below, this is where it gets cool. Move with angle. We will pass in the final move angle, and we will pass in our speed, which is derived here. And that should be it. And then we drive the car. We're done. So fingers crossed. Fingers crossed.
Test it first.
Yeah. Fingers crossed it works the first time. I'm gonna comment this out just because I want to see it logging first. What is it? It's gonna be based off of 0 to 1 coordinate system. We need it based on 100, so we're probably gonna have to multiply by 100. I think,
Oh yeah.
because it's based off of one
percentage.
Yeah. But that is quite all right. That is a good problem to have. Another truck.
Nodule math has no dist.
Okay, you know what? That's getting really irritating.
What's cache, dude?
So apt-get and apt-cache. Apt-cache is like, so apt-get actually the tool to install stuff. Apt-cache is like able to search and get information about things. Why they made them separate tools, I have no idea. But if you want to search for something, use apt-cache, and if you want to actually install the thing you search for, use apt-get.
Okay.
Why that's true, I don't know. I don't know enough about it, but so what I'm looking for is I want Python 3.8, and I don't know how to get it. I was expecting just upgrade to just work, but it did not do what I wanted to.
Python's weird for that. Python, it's like 3.7 is like a lot of people use 2.7.
Yeah,
Still.
yeah, because I mean 2.7 and 3. Whatever is significant changes. Which is
So like Python, it's almost like they don't want you to update by accident.
it's like 3.9 is there. Yeah, well maybe. Oh no, am I frozen? No. Ugh. That's frustrating. Yeah, maybe it literally.
How's your day going, Nacho Kitty? Oh, I don't know if she's still there. She might not be.
3.8. How do I search for this? It's been so long since I've used Linux. Now we're talking. That's not anything what I wanted. So why did that just not work? I just upgrade. Maybe app cache info. Show Python 3.
Sudo apt install Python 3.8.
Okay, so literally just called that. App cache show Python 3.8. See, that's See, that's weird. I can't find it. Apt-get update. Um,
Is it working?
no, I'm just doing the registry again. So 3.7 is the latest. So every time I say update Python, it's saying, hey, I'm only going to get 3.7 for you. I do not want to compile from source, which is what they're describing here.
Wait, what did that one say? The first one said it's not available on Raspberry Pi. The top one. Up higher. Or
Yeah, he's trying to look at apt-get. And he's saying he's only finding 3.7, which is what we're having. And this person's saying, yeah, that's what's actually installed in the registry that's used by. So when we go apt-get update, it says, all right, give me all the registry that is all the things you can install on this Raspberry Pi. And it doesn't look.
Here, how about we just find what is it? Math.dist.
Yeah, well,
Dist.
we could just re-implement it. It's
Uh-huh.
it's simple. It's just I just very much like to use like built-in stuff. Or if we're looking at docs, the reason why I wanted is because if we're looking at documentation, I don't want to. Everyone's talking about building it from source. I'm very much not interested in doing that. Okay. So yeah, everyone's building it from source. I'm not interested. So let's skip that, and we will just re-implement dist. Okay, let me see. So we'll re-implement from source. So how something works if it's Cartesian like this. So if we have we want to get the distance between 2 points. Distance formula. Khan Academy. Yes, I think everyone should know about Khan Academy. So this is a great time to use them as a resource. If it loads. It's distance formula. So this is one of those things. It's the square root. Yeah, this is like a squared plus b squared equals c squared. It's a Pythagorean theorem.
Okay, they have it already.
Roughly equivalent. Oh god dang it! Oh, and it's zipped.
What does it zip mean?
Oh, I don't know. But
So yeah, square it. It's just this. This
just
is all
that.
you need.
Okay,
here.
so
Square
let's
root of
go
the
back.
sum. It's the square root of the sum. Yeah, that makes sense.
that makes sense. This is square root of the sum. So we're just gonna take this. We'll edit it slightly because we don't actually need it to be in that format.
What's the zip mean? You know?
Yeah, I'll show you in a sec. I haven't used it in a while, but oh no, it's happened already.
You call it a quick break if you want.
Yeah, let's just get this working at least for 3, 2. So P and Q. We want the square root of the sum. Let me see here. So actually, this is the formula I wanted.
Square root of the square root of the.
Oh, it didn't copy. So it's d is equal to the square root of the difference between your x coordinates and the difference between your y coordinates squared. So difference between your x coordinates. Oh god, this thing is really getting in my way. It's not letting me type. So it's the sum of the square root. Let me just break this down a little bit. I'm not going to use zip. I don't need something like that for this. So we're summing. This is going to be squared just times by itself, and this is going to be in this case q So x is 0 coordinate. And p is a 0 coordinate. So it's the difference between them and then sum their squares. So we have this. I'm just going to break it down a little bit so it's easier to read. And actually, so they're using the sum method because then you can pass it a bunch of arguments, but we don't need it like that.
It's been a while since I've done math.
Yeah, me too. Like a lot of the stuff we used to do a lot, right? But now. So Pythagorean theorem, in this case, we want to get the, what is it, the distance for the length of hypotenuse or something. That's probably what's going on. So we have 2 different points. We have y coordinate, which is 1. We have the x coordinate, which is position 0. We have the first point is q, or the first point is p, and the second point is q. So it's the difference between their x coordinates, and then times, so then square it, so times by itself, and the difference between their y coordinates, square it, so times by itself, and then add them together, and then square root of that. So that is our distance function. So we can replace, boom, this. And we do not need Python 3. No, 3.8.
You need to make sure that's magnitude. If you have it.
Magnitude, yeah. Wait, what did I say?
Well, to do the calculation inside that, you have to, since it's, well, when you square it, you lose your, when you square it, you lose your negative. Never mind, ignore me.
Yeah. It's okay. You wanted to absolute it. You said make sure it's absolute, so you were asking. Right?
Yeah,
Okay.
but it's okay.
So angle with speed. So we're just gonna print this message here.
What did I say? I said magnitude. Magnitude first. But
Yeah, but we wanted to make sure the magnitude was an absolute value.
yeah.
What you were actually asking.
Yeah.
So at this angle, we're going to use this speed value. So at angle 0, I'm now full speed, and I'm going around. I'm now full right, roughly 0. I'm at full speed. I'm going about half, and this is me at 0 with speed 0. So I think this is working beautifully. In which case, we are now in a position where we can test this. We can pass speed and angle, and we should be able to drive the wheels. How are you feeling? Do you want to take a short break before we drive the thing?
Yeah, let's take a short break and get our stream back up and running at full capacity, and then we'll be back in less than 5 minutes probably.
Yeah. Maybe a little snack break.
Little snack break.
All right, everyone. Thanks very much. Talk soon.